Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Now, my theoretical physics mentor, Dewey B. Larson, was also a theoretical economist, as I am. And what I've done is to make not only his theoretical physics work fully computational, I've made his economics work fully computational. After all, I have great software, whereas Dewey certainly did not in his lifetime. I have FileMaker and MathCAD, and most of my papers are written in MathCAD, like this paper I'm going to give today, at least the first 30 minutes of it. So this is the title of the paper is Theory of Microeconomics and Macroeconomics, Larsonian Econophysics. This is real scientific economics. It completely supersedes Keynesian economics and all the other nonsensical economic theories out there, just as the reciprocal system supersedes most of modern theoretical physics. This is version 2.0 of the paper. I'm going to do this paper in installments of 30 minutes. So it's going to be a multi-part series of screencasts. Okay, you can follow along. I'm going to annotate the paper as we go. So first off, we have the abstract, of course. This paper presents a computational version of the theory of microeconomics and macroeconomics developed by scientist engineer D.B. Larson. Unlike most economic theories, Larson's theory is based on scientific methodology, not sociology or, quote, social science, and thus can be considered econophysics. It identifies the fundamental component of the economic mechanism and the fundamental equation underlying all economic transactions. The theory posits 17 principles from which all theoretical deductions are made. Thus, the theory is axiomatic, unified, and general. This paper derives detailed equations to solve the maximization problems of the representative producer-retailer, the representative worker-consumer, and the representative country or region as a whole, including the GDP, which is gross domestic product, the growth rate, and the inflation rate. The paper shows how the aggregate price level is affected by numerous factors, which we'll go into great detail, and shows the means by which it can be kept constant while letting the free market set interest rates. So in this system, preferably the Fed would never set interest rates, the market would. The calculations that I'm giving here are verified by comparison with actual economic data. Okay, so we have these keywords: microeconomics, macroeconomics, econophysics, purchasing power theory. Purchasing power is very important in this theory. And the fundamental equation of economics. Okay, so that's the abstract. Now let's go to the introduction and literature review. Dewey B. Larson is best known for his work on the reciprocal system of theoretical physics. What's mostly unknown is that he was also a fine theoretical economist. Reference 1 is his work on microeconomics. And by the way, we'll go back to the references at the end of the paper. But reference 1 is his work on microeconomics, and reference 2 is his work on macroeconomics. Both also contain recommendations for government policy. Reference 1 gives policy recommendations to maximize employment. Reference 2 gives policy recommendations to eliminate the booms and busts of the business cycle so as to create permanent prosperity, a consistently growing economy. As with his work in theoretical physics, Larson begins his economics theory with a set of fundamental principles and states the fundamental component of the economic mechanism: purchasing power. He then gives the fundamental equation of economics: P equals B divided by V. where P is the unit price, B is the nominal money purchasing power of the good or service, and V is the number of units. This paper will apply different forms of this equation to cover all of the major concerns of economics. Conventional economic theory does not have a fundamental equation or a fundamental set of principles. Many different models of theoretical economics exist: classical, neoclassical, Keynesian, neo-Keynesian, monetarist, rational expectations, market clearing, representative agent, dynamic stochastic general equilibrium, real business cycle, overlapping generations, and others. The author has reviewed selected works by the most prominent current economists, including Mankiw, Abel, Bernanke, Fisher, Auerbach, Kotlikoff, Blanchard, Barrow, Williamson, Nellis, Parker, Karlberg, Gartner, Tumovsky, Wessels, Miao, Romer, and Intrigator. The economics literature is vast, but the references at the end of the paper provide a representative sample. So now we're going to review some of the literature here. Mankiw's work, reference 3, discusses the economy in the long run, in the very long run, and in the short run. At the end of the book, page 600, he says, quote, "The current state of macroeconomics offers many insights, but it also leaves many questions open." Mankiw is a neo-Keynesian. The work by Abel, Bernanke, and Khrushchev, reference 4, focuses mostly on the conventional IS-LM/AD-AS model, based on the work of Keynes and Hicks. The empirical Cobb-Douglas production function is explained in detail and applied to the U.S. from 1991 to 2010. The work by Dornbusch, Fisher, and Startz, reference 5, is nicely organized and has numerous graphs. It focuses more on government policy than most of the other references. Auerbach and Kotlikoff, reference 6, develop a two-period overlapping generations model, mostly neoclassical. In the first period, lasting about 30 years, the worker saves for retirement, and in the second period, lasting about another 30 years, lives off the income from the capital invested in the first period. This is an interesting approach and is not inconsistent with the representative agent model utilized in our formulation of Larsonian Econophysics. Okay, continuing with the references here. Blanchard's and Johnson's work, reference 7, focuses on the IS/LM model and Keynesian multipliers, which, by the way, are silly, and rational expectations. It is very much at odds with what we develop in this paper. Larsonian Econophysics completely rejects all the so-called multipliers. Barrow, reference 8, uses his market clearing model and real business cycle theory to explain macroeconomics. To his credit, he discusses the Robinson Crusoe model, an isolated individual on an island, which is a good place to start in analyzing economic issues. But his equations and graphs are very abstract, and this kind of cracks me up. There are no numerical calculations in this text at all. Williamson's work, reference 9, is mostly text, but it has a fine mathematical appendix. Nellis and Parker's textbook, reference 10, is really totally non-mathematical and elementary, but it does have numerous figures and tables. Carlsberg's work, reference 11, provides useful specific functions for closed and open economies and with fixed or flexible exchange rates. The numerical examples are fictitious, though, and there's no comparison with actual economic data. Nonetheless, this work is consistent with this paper, although we won't be discussing exchange rates. Karlberg demonstrates that government fiscal policy will not work with flexible exchange rates, and monetary policy will not work properly with fixed exchange rates. Gartner, reference 12, covers in great detail various models of macroeconomics under flexible exchange rates. Exchange rates will not be discussed in this paper, but the effects of imports and exports on the aggregate price level will be. Chernovsky, reference 13, reference 22, develops a representative agent model for both the domestic economy and for international trade, stated using continuous time. The work is very abstract, but it's not necessarily incompatible with what we show in this work. And we do use representative agents in Larsonian Econophysics. In recent years, there has been a remarkable proliferation of economic data freely available on the web. References 15, 16, 17, 18, 19, and 27 provide the data we will use in this paper, together with a few company annual reports. Reference 20 by Reisman provides a modern Austrian view of microeconomics and macroeconomics and a solid critique of Keynesian economics. It is mostly non-mathematical, but he does give an equation which is quite close to the fundamental equation of Larsonian Econophysics, and see the note in the reference given. So that's quite interesting. So Reisman came pretty close. Reisman or Reisman, I'm not sure how it's pronounced. Reference 23, Meow's book, is mostly microeconomics, but it does have a little macroeconomics. The equations are based on discrete time rather than continuous time. Our equations are stated in discrete time likewise, so it's useful to look at the equations given in this book. Reference 24, Romer's work, is the only advanced comprehensive work studied for this paper. The equations are very detailed and useful, and the solutions manual is excellent. Romer presents numerous models and critiques every one of them, all of them. Reference 25, a Introligator, is still the best organized, clearest work in economic optimization, which is a favorite topic of mine. It's very helpful in understanding the general equilibrium of the economy at any point in time. Reference 27, Bastiat's model, Bastiat's most well-known work, is still the best statement of minarchy and laissez-faire capitalism. Pareto, that Italian economist, later showed that this is the system of maximum production. Laissez-faire capitalism is the system of maximum production. Reference 28 is the author's doctoral dissertation. It includes a thermodynamic first law energy analysis and a thermodynamic second law available energy analysis for a regenerative Brayton cycle engine. As will be shown in the next section of this paper, purchasing power in economics is analogous to available energy in thermodynamics. So let me repeat that. Purchasing power in economics is analogous to available energy in thermodynamics. Okay, we covered the references. Now the nomenclature, or the table of symbols. I don't know if I should, well, I guess I will. Normally I skip this and I explain the symbols as we go along, but I think it's important here to take a look at what all the symbols we have in this paper. So A sub prod 1 equals change in productivity, output per worker, in year 1, and it's a decimal. A sub vol 1 equals change in volume of production due to change in number of employees or work hours, decimal. Capital B equals general expression for purchasing power. Capital B sub aggregate equals general expression for aggregate purchasing power created or expended or consumed in a year. Again, it can be purchasing power can be created, it can be expended, or it can be consumed. B sub aggregate 0 equals aggregate purchasing power created, expended, consumed in year 0. Year 0 is the base year. Remember that? Year 1 is the following year. B sub aggregate 1 equals aggregate purchasing power created, expended, consumed in year 1. That's the following year from the base year. B sub cons underscore nom equals purchasing power consumed in dollars. Often a subsequent nom will be left off because that's just assumed to be a nominal price. B sub cons real equals purchasing power consumed in goods. In goods, not in dollars. B sub nom equals purchasing power dollar sign. Often the subsequent nom will be left off because that's just assumed. B sub prod underscore nom, purchasing power produced in dollars. Often the subsequent nom will be left off of that. B sub prod real equals purchasing power produced in goods, not in dollars. B sub real equals purchasing power in goods. Okay, then we go to small b sub 1 equals investment income, interest, dividends, rents, etc. of the worker-consumer in time period T. Capital C sub 1 equals nominal aggregate consumption in year 1 in dollars. C sub res 1 equals change in the consumer reservoirs. It's the negative of private sector savings rate, and it's a decimal. So this is an important number here. Change in the consumer reservoirs. Either we put more money into the reservoirs or we take money out of the reservoirs. So it's the negative of the private sector savings rate. C sub 1 equals cost, consumption of worker consumer, and time period T. I'm sorry, it's C sub T equals cost, consumption of worker consumer, and time period T. Okay, now CPI underscore 0 equals the consumer price index for year 0, the base year, and it's always set to 100. CPI sub 1 equals the consumer price index for year 1, and that's the following year. Def sub 1 equals the nominal deficit of federal government in year 1. E sub I0 equals fraction of volume in year 0, the base year, from imports. Fraction of volume in year 0 from imports. Okay? E sub by 1 equals fraction of volume in year 1, the following year, from imports, and it's a decimal. Capital F, capital V equals future value of stream of payments or savings. F sub W1 equals change in average wage rate in year 1, decimal. Capital G sub 1 equals nominal total government spending in year 1 in dollars. G sub 1 check, a check calculation for nominal total government spending in year 1. So that just confirms the calculation. GDP sub 0 equals gross domestic product in year 0, the base year, in dollars. GDP, or whatever currency you want to use, it's fine. GDP sub 1 equals nominal gross domestic product in year 1, the following year. GDP sub T observed equals observed gross domestic product in year 1 stated in base year dollars. GDP sub 1 true because gross domestic product in year 1 stated in base year currency. Okay. G sub 1, that's small g sub 1, equals change in the Federal Open Market Committee purchases or sales of government bonds to public in year 1. It's a decimal. It's the same as the change in M0. M0 is the base money supply. G sub 1 is a very important factor. That's what the Fed does. It either prints more money or it takes the money out. So that's G1. G sub 1 opt equals change in FOMC purchases or sales of government bonds to the public in year 1 so as to keep inflation exactly 0. G sub T opt M1 equals change in FOMC purchases or sales of government bonds to public in year 1 so as to produce a deflation of 1%. Decimal. So that's opt M, that's optimal minus 1. And that, it's just my opinion, is that a deflation rate of 1%, which is an inflation rate of minus 1%, is really the best way to go. Of course, we don't want any major deflations that would disrupt the economy. But a deflation of 1% every year would, in fact, stimulate savings, investment. It would make our purchasing power grow each year, actually. Okay, GR sub 1 equals growth of GDP in nominal terms percent. GR1 true equals growth of GDP in terms of base year currency. Capital I sub 0 equals aggregate private investment in year 0 dollars. I sub 1 equals nominal aggregate private investment in year 1. I sub 1 true equals aggregate investment in year 1 stated in base year currency. Import, or imp sub 0 equals nominal aggregate imports in year 0. Imp sub 1 equals nominal aggregate imports in year 1, so in dollars. Inflation, INFL sub 1 equals inflation rate in year 1%. INFL T equals inflation over T years. So that's a total. Capital K sub 0 equals capital stock in year 0 in dollars. K sub 1 equals nominal capital stock in year 1 in dollars. K sub 1 true equals capital stock in year 1 stated in base year dollars. Small k sub c sub 1 equals coefficient of cost of producer hyphen retailer relative to that of the average firm in the sector, normalized to 1 for the average firm. We're going to find these coefficients to be very important. Okay, so we got 10 minutes to go here. K sub R1 equals coefficient of revenue productivity of producer retailer relative to that of the average firm in the sector, normalized to 1 for the average firm for time period T. Capital M 0 sub 0 equals monetary base in year 0 in dollars. M 0 sub 1 equals monetary base in year 1 in dollars. Capital N sub 0 equals aggregate number of employees in year 0, full or part-time. Capital N sub 1 equals aggregate number of employees in year 1, full or part-time. And X sub 1 equals net exports minus imports in year 1, dollars. And X sub 1 true equals net exports minus imports in year 1, stated in base year currency. N sub P underscore R equals number of aggregate representative producer retailers. Small n sub E equals number of employees of a particular producer retailer. Capital PV sub P underscore R equals the net present value reflected back to time 0 of a particular producer retailer or a particular industry sector, dollars. PV sub W underscore C equals net present value of worker underscore consumer in dollars. Small p equals general expression for unit or average price. P sub aggregate underscore 0 equals the aggregate unit price level for year 0, the base year. And that's, of course, dollar per unit. P sub aggregate underscore 1 equals the aggregate unit price level. I'm missing an L there, level for year 1, the following year. And that's dollars per unit. P sub nom equals the unit or average price dollars. And of course, the subsequent nom will often be left off. It's just assumed. P sub real equals the price in goods, which is actually the real price. Capital res, R-E-S, underscore P sub R equals current equivalent monetary reserve of producer retailer. So that's just a reserve, like savings. Res underscore W underscore C equals current equivalent monetary reserve of the worker consumer, dollars. Small r underscore 1 equals effective rental price of capital. That's the interest rate for year 1, decimal. R sub 1 true equals effective rental price of capital interest rate after depreciation and taxes in decimal. R sub P underscore R equals nominal discount rate for time period representing perceived risks of the firm and the interest cost of borrowed funds. Assume not to change for periods T equals 1 to T. Capital S sub 1 equals aggregate nominal public and private savings in year 1 in dollars. Capital S sub 1 true equals aggregate public and private savings year 1 stated in the base year currency. Small s sub 1 nominal savings of worker consumer in year 1, dollars. S sub T equals savings of worker consumer in time period T, dollars. Capital T C sub 1 equals nominal aggregate total cost of producer retailers in year 1 in dollars. Capital TC sub 1 equals, T sub T equals total cost or expense of average producer retailer in sector for time period T, again in dollars. Capital TC underscore W underscore C sub T equals total cost or expense of worker consumer in time period T in dollars. Capital T R sub 1 equals nominal aggregate total revenues of producer retailers in year 1 in dollars. T R sub T equals total revenue of average producer retailer in sector for time period T. T R W underscore CT equals total revenue of worker consumer in time period T. That's in dollars. Capital T sub P underscore R equals total number of time periods considered. That's the time horizon for the producer underscore retailer, and that's in years. Capital T sub W underscore C is total number of time periods considered, time horizon for the worker consumer, and that's in years also. Capital TXP sub 1 equals nominal total taxes paid out by federal government and transfers to worker consumers in year 1 dollars. TXR sub T equals nominal total taxes received by federal government in year one. I'm sorry. It's capital TXR sub 1, nominal total taxes received by federal government in year one in dollars. Lowercase t equals the time period subscript in years. TR sub 1 equals transfer payments made by federal government in year one, dollars. TR sub 1 true transfer payments made by federal government in year one stated in the base year currency. Capital V equals volume of goods and services in number of units. Capital V underscore aggregate underscore 0 equals aggregate volume of goods and services in year 0, the base year in number of units. V sub aggregate 1 equals aggregate volume of goods and services year 1, the following year in number of units. Capital V vel underscore 0 equals velocity of circulation in base year. And vel sub 1 equals velocity of circulation in the following year. And that's a very important calculation, by the way. Small v sub t equals change in velocity of circulation of the monetary base decimal. W sub 1, I'm sorry, that was v sub 1. Getting these ones and t's confused. Anyway, W sub 1 equals nominal wage or salary per year of worker consumer in year 1. WB sub 1 DISP, that's disposable income of worker consumer in year 1. In dollars, W sub 1 true equals, well, that should be wage. Okay, not wager, but wage or salary per year of worker consumer year 1 in terms of base year dollars. To get this all finished here. W sub 1 equals wage or salary of worker consumer in time period T in dollars. Capital X sub 0 aggregate total of exports in year 0 in dollars. X sub 1 nominal aggregate total of exports in year 1 in dollars. Small x sub 0 fraction of aggregate volume in year 0 of exports decimal. X sub 1 fraction of aggregate volume in year 1 of exports decimal. Y sub vol 1 change in capacity utilization for the production of both goods and services decimal. Z sub P1 change in price level due to change in capacity utilization and savings in decimal. Beta equals fraction of aggregate income going to the suppliers of capital. Delta 1 equals depreciation rate of capital stock in decimal. Tau sub B1 equals tax rate on business earnings for year 1 decimal. Tau K1 equals tax rate on interest or rental income for year 1 decimal. And tau sub W1 equals tax rate on wages or salaries for year 1 decimal. Okay, just one note here, a black square in the upper right of an equation, and that's a MathCAD feature, means that the equation is disabled for money in MathCAD. This is dumb because not all variables in the equation have been given numerical values. Currency is given in US dollars if you are not an American, and simply substitute your own currency for the graphs. Some variables have a doubled first letter, and that's for the graphs. And the origin is set to 1 so that matrices and vectors start at index 1 instead of 0. Okay, I'm going to stop right here. So next time, we will be discussing the principles of Larsonian Econophysics. So please stay tuned for that. Okay, please study this paper in great detail, and I'll show you the Optimal Economist software program, which is based on this paper, after we go through all the pages of this paper. Okay, so thanks for your attention. That wraps it up for today.